In this video, we'll look at improper integrals type 1. Up first, some definitions. If the integral from a to t of f of x exists, then the integral from a to infinity of f of x we can rewrite using a limit. Essentially, we will replace the upper limit infinity with t and use a limit to force t to approach infinity. Similarly, if we have negative infinity to b, then we will replace the negative infinity with t and force the limit t to approach negative infinity. Also, we can look at integrals that go from negative infinity to infinity. In this case, we will split it up into two separate integrals and evaluate those separately, again using limits. In this example, notice that we have the integral from 3 to infinity. Let's start by rewriting that as limit as t approaches infinity of the integral from 3 to t. Notice we're changing that upper limit of infinity to t, and then the limit is going to force t to get really, really big. We'll copy the inside. That is x minus 2 to the 3 halves dx. And I like to rewrite it. Let's just rewrite that function. Copy the limit. Integral's the same for now. And I'm going to rewrite that function as x minus 2 to the negative 3 halves. From here, we can do a u substitution. U would be x minus 2. Du would simply be dx. We now have the limit as t approaches infinity of the integral of u to the negative 3 halves du. And notice, since we changed our variable, we need to change our limits of integration. The lower limit was 3. If we replace x with 3, the lower limit for u will be 3 minus 2, which is 1. And our upper limit was t. If we replace x with t, the upper limit is now t minus 2. We now have the limit as t approaches infinity of, we can evaluate that integral now. We get negative 2 u to the negative 1 half. And we want to evaluate that integral from 1 to t minus 2. Limit is still out front. Now we'll plug in the upper limit to the function. That is negative 2 times t minus 2 to the negative 1 half power. Minus, now we'll plug in 1 to the function. So we have minus negative 2, 1 to the negative 1 half power. Continuing to simplify, we'll just copy the limit for now. I'll rewrite that first term. We have negative 2 divided by the square root of t minus 2. And then we get negative negative, that'll become positive. 2 over the square root of 1 is just 2. Now that we've simplified on the inside, we can actually evaluate the limit. Notice that t is going to infinity. So in this first term, t is getting really, really big. It's approaching infinity. If the denominator is getting big, the fraction is approaching 0. So we have 0 plus 2, which is 2. Since we get a finite answer, we can say that the original integral is convergent. In this example, we have another type 1 improper integral. We'll start by rewriting this using a limit as t approaches infinity of the integral from -2 to t. Notice we are replacing the upper limit infinity with t and forcing t to go to infinity. Then we'll copy the inside of that function, dx. At this point, we can go ahead and integrate. We'll just copy the limit for now. The integral of 1 over x plus 4 is the natural log of the absolute value of x plus 4. And we are evaluating that from -2 to t. Copy the limit. And we'll plug in those limits of integration. We have the natural log of the absolute value of t plus 4 minus the natural log of the absolute value of -2 plus 4. At this point, we haven't quite simplified on the right side, but that's okay for now. Let's focus on this first term and evaluate the limit as t approaches infinity. Think about what the natural log function looks like graphically. It looks something like this. And we're saying that t is getting really big. Or on the graph, what's happening as x gets big? As x approaches infinity, notice that the function is also approaching infinity. So this term is approaching infinity. And if that term is approaching infinity, the entire limit is approaching infinity. So we would say that this particular integral is divergent because we get positive infinity. In this example, we again have a type 1 improper integral, but notice that this time the lower limit is negative infinity and the upper limit is positive infinity. In this case, we want to split this up into two separate integrals. The first one will go from negative infinity up to a number, and we have options for that upper limit. Let's say we split the interval in at 0. Seems like an easy value to use, and we'll use the inside that just stays the same. And then the second integral will go from 0 to positive infinity. And we'll just copy that function. At this point, we can rewrite it using the limit notation. We have the limit as t approaches negative infinity. Integral from t to 0. Notice this time the lower limit was negative infinity. We replace it with t and force t to get really small. X divided by x squared plus 1 dx. And then the second integral we will again replace with a limit. This time t is going to positive infinity, and we will replace the upper limit of that integral with t. At this point, we want to integrate, but it looks like we need a u substitution to help us do that. Let's let u be x squared plus 1. Then du is 2x dx. We'll divide both sides by 2, giving us 1/2 du equals x dx. Now rewriting these, we have the limit as t approaches negative infinity of the integral, actually it's 1/2 out front, integral of 1 divided by u du. We'll need to change those limits of integration. The upper limit was 0. Plugging in 0 for x, we get 1. The lower limit was t. Replacing x with t, we get the lower limit is now t squared plus 1. Then the second limit, just copy that for now. we have 1/2 the integral of 1 divided by u du. And again, we need new limits of integration. Upper limit used to be t, replace x with t, and we get the upper limit is now t squared plus 1. Lower limit was 0, replacing x with 0, we get the lower limit to be 1. From here, let's evaluate those integrals. Again, we're just going to copy the limit for now. We have 1/2 integral of 1 divided by u is the natural log of the absolute value of u. And we are evaluating that from t squared plus 1 to 1. Copy the second limit. 1/2. And again, evaluating that integral, we will get the natural log of the absolute value of u. And we're going from 1 to t squared plus 1. From here, we can plug in those limits of integration. For now, we'll just copy the limit. We have 1/2 times the natural log of the absolute value of 1 minus the natural log of the absolute value of t squared plus 1. Plus, copy the next limit. T is going to infinity of 1/2 times the natural log of the absolute value. Upper limit is t squared plus 1 minus the natural log of 1. At this point, I want to focus on just this one piece. Recognize the natural log there. We saw that in the previous example. As t approaches infinity, the natural log function is also approaching infinity. So that part is going to infinity. If that one piece goes to infinity, we don't even need to consider the rest. We can say that the original integral is divergent.